Class, in this lesson we are going to see another problem on acids and bases. These questions are challenging, and what you needed to understand is here we are going to combine pH with the titration question. Now we have to use the stoichiometry carefully so that we get our answer what we want. Anytime you are given pH and it has to do with the base, it's better to use that formula pH plus POH is equal to 14. Here the base volume is given and the pH is given. If any time pH is given, we can find the concentration of the solution. Then this is added to sulfuric acid. And what they want is they want the concentration of barium hydroxide. I'm going to teach you how to do that one. Then we can calculate what is the amount of barium hydroxide that is added. Then the pH of the final solution. So acid is added to the base and they want the pH of the final solution. We don't know which one is excess. But if we do calculation, we will be able to find out. Because there is no clue is given, but you know how to find a limiting reagent from the previous year. In grade 11, we have learned how to do the limiting reagent. Okay, let's do this one. What we are going to do, the first part is starting with pH. pH is 2,1. I'm going to use this formula. pH plus POH is equal to 14. So the pH is 13,6 and POH is equal to 14. When you do that, you get POH is equal to how much is that? It is 0,4. Now let's use this formula. POH is equal to negative log of OH minus. So now it is 0,4 is equal to minus log of OH minus. Let's take the negative sign to this side. Negative 0,4 is equal to log of OH minus. So let's find out the concentration of OH minus. What we do is shift log minus 0.4. You will get it 3,98. So the concentration of OH minus is equal to 0,398 mole per decimeter cube. That is a concentration of hydroxide ion. But concentration of hydroxide ion doesn't give you the concentration of the solution. Now we have to write bases, means we write dissociation equation. What is the dissociation equation for barium hydroxide? Ba2 plus 2OH minus. So this one is 0,398. So this one is 2 moles. What about this one? 1 mole. So let's find out what is the number of moles of barium hydroxide. Sorry, the concentration of barium hydroxide. So which is going to be, you have to divide that by 2. So 2 mole is this, 1 mole is that one. So it's going to be 0,398 divided by 2, which is equal to 0,199. If I'm not mistaken, let's check the calculation. 0,398 divided by 2. What is going to be the value? 0,199 mole per decimeter. So this is the first part of the question. We have found out the concentration of barium hydroxide. Now we have to do the second part, calculate the number of moles. We can use the formula here, 2,2. Number of moles is equal to C times P. Your C is 0,199 and the volume we have to convert into decimeter cube, 0,025. Whenever we use this formula, the volume must be in decimeter cube because concentration is expressed in decimeter cube. 0,199 times 0.025. Let's do the calculation and see what do we get here. 4,975. 4,975 times 10 to the power of minus 3 moles. Now we have to do the third part of the question. What is the third part of the question? Calculate the pH of the final solution. To find the pH of the final solution, we know the number of moles of barium hydroxide. Okay, this is your number of moles of barium hydroxide. Then what is the number of moles of sulfuric acid? Let's do the calculation. Number of moles of sulfuric acid is, we are going to work with 2 comma 3 is equal to C times V. What is the C here? The C for the sulfuric acid, is 0, 0,15 and the volume is 0, 0,04. Do the calculation and see what you get here. 0.15 times 0.04. What is the value that you get here? 0,006. 0,006 moles. Okay, and here it is 0,4975. So when you look at the mole ratio, in grade 11 you learned how to do the limiting reagent. If the number of moles of, we have to divide by the number of moles to find the limiting reagent. For barium hydroxide, the number of mole is 1. When you divide it, you get the same thing. When you divide the number of moles of sulfuric acid by 1, you get this. Among these two, which one is the smallest? The smallest one is this one. So barium hydroxide is the limiting reagent. The one which has got the smallest number of moles after dividing by the number of moles in the equation is the limiting reagent. So which one is excess? Number of moles of sulfuric acid excess. The mole ratio is 1:1. So if this is 0,4975, so what will happen? The excess one is 0,006 minus 4,975 times 10 to the power of -3. Let's do the calculation. And find out what is going to be the answer here. 0.006 minus 4.975 exponential minus 3. Let's see what's going to be the answer here. 1,02.5 times 10 to the power of -3 moles. That is the excess amount of sulfuric acid. Now, this is the sulfuric acid that we have got. This is number of moles. But now we have to find out the concentration of sulfuric acid. What is the concentration? C is equal to N over P. Here, what is the N? We have got it. But the number of moles, the volume is the total volume. Let's add these two volume. 25 plus 40 is 65. And we have to divide by 1000. So you will get 0,065. So let's get the concentration of sulfuric acid divided by 0.065. So we have to divide, it's in the total solution. So it's going to give you 1,576, or you can say 577 times 10 to the power of -2 mole per decimeter cube. But now to find the pH, we need H3O+. We have got only concentration of sulfuric acid. But sulfuric acid is a diprotic acid. So what is it going to give you? It is going to give you 2H3O+. So once if you know concentration of sulfuric acid, we must multiply by 2 to get the concentration of H3O+. Concentration of H3O+, you must multiply this one by 2 times 2. What is it going to be the value? It is 3,15. 3,15 times 10 to the power of -2 mole per decimeter cube. Anytime we want to find pH, we need to know the concentration of H3O+. Now we are going to find out the pH formula, you know, and we know how to apply that one. So pH is equal to negative log of H3O+. pH is equal to negative log of 3,15 times 10 to the power of -2. Let's do the calculation. So let's see what happens. Negative log of, start the bracket, 3,15 exponential -2. Let's see what is the answer here. It is 1,50. So we can find the concentration, pH of the final solution, which is 2, 3. Thank you.